Hey, we're gonna get into some fun stuff for pre-calc finally. So this is gonna be 6.2 part 2. So we're gonna learn about the product rule and then the quotient rule, which is lots of fun too. So product rule, guys, product is a function times a function, right? So there's gonna be a couple different ways you might see some notation here. Um, this first way, if you have f times g, so function f times function g, and you want to take the derivative of that, we can't just say the derivative there, because that would be like f times g prime. So we're going to put this in parentheses. Alright, so it's really f times g, and we want the derivative of that. It's going to be your first, so f times the derivative of the second. So the derivative of g is going to be g prime, plus, and then you just do it in reverse order, okay? So this was the first times the derivative of the second, and now we're going to do the second times the derivative of the first. It really doesn't matter which order you do these in. Okay, you could really do the second times the derivative of the first plus the first times the derivative of the second. But that's going to be basically it. Another way to think about this, let's say h of x equals f of x times g of x. And we want to find the derivative of h, this would be h prime. It's really going to be the first times the derivative of the second plus the second times the derivative of the first. Okay. I think I'm going to put that down in words, okay, because whenever we're doing the product rule, I really want you thinking that. Okay, so you say the first. When I say the first, it's just referring to my first function times derivative of the second. And when I say second, I'm really saying the second function that I'm multiplying together. So the first times the derivative of the second plus the second times the derivative of the first. Okay.
The really important thing that you guys understand is that this is not like the power rule where it's just individual terms one right after the next, where you can just take the derivative of each piece one right after the next. Totally different. So if you had a product and you just said, oh, it's the derivative of the first times the derivative of the second, 0 points, nothing. You have to recognize that it's product rule.
Another thing you guys have to remember is going to be a plus here, okay? A lot of students will mix up and put a minus here just because the quotient rule is going to have a minus in it. So make sure product rule definitely has a plus in between them. All right, let's get on to some fun here. Let's actually do a problem. Yeah, all right. So let's check out this example. F of x is going to equal x squared plus 1 times the square root of x. Okay, guys, before we do this, I want to point out you guys would be able to avoid doing the product rule here because this is really x to the 1/2 power. You could distribute it in. Okay, but we're actually focusing on the product rule here. There's going to be times when you have to use the product rule. Okay, so we want you to practice on things like this right now just because you don't know that many derivatives. Really, when you'd be using the product rules, maybe you're going to have like e to the x times a polynomial or sine of x or cosine, so logs, those all those could be in here when you're going to have to use the product rule. You guys just won't learn that till next year yet. So, to find the derivative, I'm going to say f prime. Okay, is going to equal the first. So I always like to use brackets. It kind of helps me keep my place here so I don't lose it where I'm at. So that's my first times the derivative of the second. Now the derivative of the square root of x. So remember, this is really x to the 1/2 power. So we're going to bring our exponent out front and then subtract 1 from our exponent. So this is going to be 1/2 x to the negative 1/2. Okay. So I forgot where I'm at. So let's restart. We got the first times the derivative of the second plus the second, so x to the 1/2, times the derivative of the first. And I'm going to take the derivative of x squared plus 1. The derivative of x squared is going to be 2x. The derivative of 1 is going to be 0, so we don't need to write that. Alright, and that's your derivative. Okay, that is the right answer, but we want you to clean it up. We want you to write it in the same kind of notation, maybe that you started off with. So let's see how we can clean this up. So one thing I'm probably going to want to do is distribute both of these. Okay, so 1/2 times 1 is still going to be 1/2. X squared times x to the negative 1/2, once you just add those together. So 2 plus a negative 1/2 is going to make x to the 3/2, because that'd be like 4/2 minus 1/2. Alright, so that was just to my first term here, and then we have a plus 1/2 x to the negative 1/2, plus over here we get 2x times x to the 1/2. Well, this is just going to be 2 times 1, which is 2. X times x to the 1/2, you're just adding your exponents. So if this is 1 over 2, this is really a 1, or 2 over 2. So it's going to make x to the 3 over 2. Hey, x to the 3 over 2, these are like terms, so we're going to combine them together. So we're going to add these together. 2 plus 1/2 is really going to make 2.5, or 5/2. 5 over 2, x to the 3/2, plus 1 over 2 square roots of x. When I bring that down to my denominator. Maybe we want to make this all one fraction. So I'm going to make sure I have, let's rewrite this. If I'm going to make it all one fraction, this is really in my numerator up on top. So I'm just going to write it a little bit more like that. Okay, so to get a common denominator, my least common denominator is going to be 2 square roots of x. I'm going to multiply this guy by the square root of x over the square root of x, which is really x to the 1/2 times, or over x to the 1/2. Hopefully that makes sense. Okay, so when we multiply this in here, we still have 5. We're going to add our exponents. 1/2 plus 3/2 makes 4/2, which is just going to be x squared. So we get 5x squared plus 1 all over. So we had to get a common denominator. We've got to keep that common denominator, 2 square roots of x. And that is what we call fun. Okay. Hopefully that makes sense. Yeah, so it's really just going to be the first times the derivative of the second plus the second times the derivative of the first. That's all you got to do. We should be good with one example, right?
Yeah.
Yeah. Sweet. All right, so let's do the quotient rule. This one's a lot of fun. Quotient means divide. Quotient rule. All right. So if we think about this, the rule might look like f over g. So we got that, or the function f divided by g. Let's say we want to take the derivative of that. It's going to equal, now this is where I always teach low d high. Okay? Low d high minus high d low all over the square below. Okay, say it with me now. Low d high minus high d low all over the square below. Alright, so what the heck does that mean? Low, well, let's write it out in words. Low d high minus high d low over the square below. Alright, so guys, when I say low, I'm just referring to the bottom function. When I say d high, I'm referring to the derivative of the top function. Minus means subtract. High is going to be the top function. D low is going to be the derivative of the bottom one. All divided by, so all over the square below, it's just going to be my bottom function squared. Okay? So if we were to write it out here, low is just going to be g of x. D high is going to be f prime, so the derivative of the top. Minus high d low, so high is going to be the top function, f of x. D low is the derivative of the bottom, so g prime, all divided by g of x, the bottom one, squared. Alright, hopefully that makes some sense. Let's say it a couple more times. You guys all got to say it with me. Low d high minus high d low, all over the square below. Again, low d high minus high d low, all over the square below. Again, low d high minus high d low, all over the square below.
Mind you, I say the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. But singing it, Mr. Herney.
You guys won't remember that? I never remember that. I gotta sing it. Okay, you gotta say it so many times, otherwise, because if you say it the other way, it's gonna sound weird if you keep saying it like this every single time. So make sure you look it up. Keep saying this over and over.
And in this case, unlike the product rule, you couldn't have it flipped around because subtraction is not commutative. It has to go this order. So that's the reason we make you practice singing it, to try and get the order down. And the bottom squared part, you're just going to leave as the whole thing squared. You're not actually going to square it out. Remember, we like denominators in factored form.
Another thing, make sure you have a minus here, okay? Because the product rule is with a plus, so sometimes students will put a plus here because they're thinking product rule, they get them mixed up. Make sure you keep them straight. All right, let's do an example. We'll leave this up here. All right, so let's check out g of x equals 1 plus x squared over 1. Well, let's do 1 minus x squared. We'll just keep it like that for this first one. All right. So let's have some fun. So if I want to find g prime, low d high. So low is going to be my bottom function here. 1 minus x squared. Once again, guys, I really like to use brackets because it's easy to kind of lose your place. And you just start singing the song over. So I got low d high, so I got to do the derivative of the top next. So the derivative of the top, derivative of 1 is going to be 0. Derivative of x squared is 2x. Low d high minus high 1 plus x squared d low, so the derivative of the bottom. So here the derivative of 1 is 0. Derivative of negative x squared is going to be negative 2x. All over the square below, and yes, you need to write this every single time. Okay, so guys, all you're going to do is copy that bottom equation over and then just put it in brackets, square it, and you're good. Okay, so of course we can't be done there. You guys got to clean it up. So when we clean this up, I got to distribute. So I'm going to get a 2x minus 2x to the third. Okay, so here, guys, we're going to subtract all of this. This was a negative 2x that I'm going to distribute. Okay, but negative times negative makes a positive. So I could just distribute a positive 2x and everything will be plus. So 2x times 1 is going to be a plus 2x. 2x times x squared is plus 2x to the third. Okay, now this is where a lot of people screw up and they forget to write their denominator. You got to write it every single time. You can use parentheses, I guess, if you want. Okay. Now we're not quite all done. We got to clean up just a wee bit more. Negative 2x to the third cancels with a positive 2x to the third. We're left with 2x plus 2x, which makes 4x. Okay, so g prime of x is going to equal 4x divided by 1 minus x squared squared. And that's it. You're all done.
Beautiful.
Okay. Whew, I'm kind of out of breath. So, let's just sing it again. Low D high minus high D low all over the square below. Sing it with me! Low D high minus high D low all over the square below.
Woo.
So much fun. Hey, let's do another practice one, huh? Alrighty, let's see what we got here. Ooh, this one could be a doozy.
A doozy.
A doozy. Alright, we got h of x equals 3x squared plus 2x divided by 2x to the third minus 4x squared. Alright, so we want to find the derivative. That's all we're doing this chapter, really. So h prime. So, we got the quotient rule. We got a function divided by a function. We got to use quotients. Okay? Low d high. So low is just going to be my bottom function. 2x to the third minus 4x squared. I forgot what I'm doing. Okay, that was low d high, derivative of the top. So derivative of the top. So I bring my 2 out front. 3 times 2 is 6. Subtract 1 from my exponent. Should get 6x there. Plus the derivative of 2x. Bring my exponent out front. 2 times 1 is 2. Subtract 1 from my exponents. This can be x to the 0, which is just 1. So this is going to be a plus 2. I forgot what I'm doing again. I got my brackets to tell me. Low d high minus high d low. So now it's going to be the top. 3x squared plus 2x. Okay, I forgot what I'm doing. Low d high minus high d low. D low is the derivative of the bottom. So I'll bring my 3 out front. That's going to make 6. X, I subtract 1 from my exponents, 6x squared. Same thing here, 4 times 2 is going to give me a minus 8. Subtract 1 from my exponent is just going to be x. All divided by the square below. So that's going to be a 2x to the third minus 4x squared. All of that squared. Okay, so now we got to clean this up, which is going to be so much fun. Let's just jump over here. H prime of x. Okay, so guys, make sure you FOIL, double distribute, whatever you want to call it. Okay, so my first one here, I'm going to distribute my 2x to the third. 6x is going to be 12x to the fourth. And then plus 4 x to the third. Okay, so now what I'm going to do is distribute my negative 4x squared. So this is going to be a minus 24x to the third minus 8x squared.
Nice.
All right, so there's so much going on here. I think last time I explained how I just kind of combined the negative with my negative 2x or something. Okay, what I'm going to do here is I'm just going to put a minus. I'm going to put brackets. So I'm just going to distribute this stuff. And then next step, I'm going to distribute my negative because I can't do that much in my head at once. So minus all of 3x squared times 6x squared, 18x to the fourth. And then 3 times negative 8 is going to give me negative 24 x to the third.
Looks good, looks good.
Distribute this. 2x, I get 12 x to the third minus 16x squared. I'm going to end my brackets. Put a big division bar thing. Does that division bar have a special name?
Mm-mm.
No?
I don't think so.
Just big division bar. Alright. Okay, make sure you write your denominator. It's all squared yet. Oh, yuck.
Woo!
Alright, so...
Mind you, this is the calculus, and all of this is algebra. This is where you guys screw up, is the algebra. Not so much the calculus. Like, you'll get down the quotient rule and get down low D high, high D low, but you'll screw up the algebra and your negatives. Gotta practice.
Alright, so... I don't know if you guys can see. Yeah, you can still see. Alright. So, when I do this, I'm going to combine like terms right away here. Just because I see that those are like terms. So I have a 12x to the fourth. 4 and negative 24 is going to make a negative 20x to the third. Minus 8x squared. Alright. You got a couple options. We could distribute this negative right now. I'm going to try to combine these. So that's going to make a negative 12x to the third. Okay, and now I'm going to distribute. So it's going to be negative 18x to the fourth. Here, a negative times negative 12x to the third is going to be a plus 12x to the third. Negative times negative 16x squared is going to be plus 16x squared, all divided by our denominator, 2x to the third minus 4x squared, all squared. Don't forget about that denominator. We're getting close at least. Do you have one like this on your test? I think so. And your homework, probably. Alright, so I'm going to combine like terms. 12x to the fourth minus 18x to the fourth is going to make a negative 6. X to the fourth. Alright, I'm just going to put a line through those. I'm done with that. X to the thirds. Let's box that guy. So this was a negative 20x to the third and a positive 12x to the third. It's going to make negative 8. X to the third. Alright, we're only left with x squareds. We got negative 8, positive 16, makes a positive 8 x squared, divided by 2x to the third minus 4x squared, all squared. Yeah. It does simplify more, but we're going to just call it good. Alright, that was fun. You want to go over something now?
Yeah, I'm going to take over.
Oh, thank you.
Okay,
Thank
Cody
you.
needs a break, so
I'm tired.
I'll do an example now. I'm also kind of introducing another notation to you guys on this last example. So we're just trying to give you A lot of practice. This is also why we're doing office hours on Thursday for pre-calc to go over questions that you possibly might have on product rule and quotient rule.
We did do Tuesday last week too, but nobody showed up. So we're cutting it down one day.
So it's only one day this week. Okay? So, like I was saying, when I teach the quotient rule, I don't say the low D high sum. I mean, I say it sometimes, but I usually say it's the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. What you're just going to leave is the whole denominator squared. You're not going to actually like square it out. We like denominators in factored form. Okay? So on this example, I'm going to give you y equals x squared plus 1 over the square root of x. And they're actually asking us to find dy over dx. So I'm introducing this new notation. This is called operator notation. So this is red, the derivative of y with respect to x. It just means the same thing as like y prime. So if this had been like, I think a bunch of them on your homework are a capital F of x or a capital G of x. And if they had denoted this way, then you would have found capital F prime of x or capital G prime of x, right? The derivative with the little prime tick mark. That's the easiest derivative notation. But as you get into more complicated things, and especially next year in AP Calc, you are going to have what we call operator notation. And that's what this is. So we're finding the derivative of y with respect to x. And that's how we kind of think of that, and we read it dy over dx. So you guys will have all of these different notations on your homework, and of course all of the different notations when it's time for a test over this section as well. Okay, over 6.1 to 6.4. So if I want to find the derivative of this and I realize, hey, it's a quotient, I have like this quadratic function on top and this square root function on the bottom, and you cannot just like take the derivative of each part and just put them like over top of each other. That's totally wrong. 0 points, nothing. It's got to be quotient rule. Then a lot of times you'll see like Hernie or I like show QR for quotient rule or PR for product rule when we have a function times a function, or this is a crap marker, Hernie, or a function divided by a function. But one thing that we talk about a lot with doing derivatives that involve square roots is this isn't like really calculus friendly. We don't know the derivative of a square root. We really like have to turn it into that rational exponent notation. So sometimes I will show, let's change this to be more calculus friendly first. So y is really, this isn't me taking the derivative yet, this is just me like making it more calculus friendly. Y is really x squared plus 1, those two terms, that binomial, over x to the 1/2 power. So now this is more calculus friendly. So we can actually find, in operator notation, all we're doing is taking the derivative of both sides. The derivative of y with respect to x, or dy over dx. Oh, I have to apply the quotient rule, because I have a function divided by another function. So you can sing it like Mr. Hernie does. You can think about it as the bottom function, x to the 1/2, times the derivative of the top. So the derivative of the top, well, the derivative of x squared would just be 2x. And this is a good reminder, isn't the derivative of a constant really 0? So that part goes to 0. Minus, big brackets, because we know we have to subtract the whole next part. The top, x squared plus 1, but that's a 2-termed binomial, so you have to have parentheses around it, times the derivative of the bottom, right? Or this is low d high minus high. Now I'm taking the derivative of the bottom, d low. Okay, so that's just power rule. Bring the 1/2 down in front, and then don't we leave the x the same, but decrease the power by 1. So this always like messes with your head, right? So you have 1/2 minus 1. So 1/2 minus 2 halves would give us what? Negative 1/2? All over the bottom squared. So x to the 1/2, the whole thing squared. But that's the calculus, but you're going to get like a huge other chunk of points after you do all the algebra cleanup. So when we're talking about like, you got to clean it up, you got to clean it up, you got to clean it up, you're going to get a good chunk of points from doing the calculus correctly with the quotient rule, but you're not going to get enough points until you clean it up algebraically. So because this is the part that's hard, like you got to take it seriously. And Mr. Hernie did one like this too, where he had like some rational exponents going on, and he kind of like left him in that rational exponent form. I found more recently that you guys do a little bit better on the algebra cleanup if you turn it into radical notation. And I just think it's because of like integrated curriculum, you don't practice a lot of rational exponent notation. So it might help to like clean it back into radical notation. So wouldn't this be the 2 times the x, and isn't x to the positive 1/2 power the same as the square root of x? So maybe kind of like in a clean algebra order, it'd be 2x times the square root of x. Minus, okay, I'm going to clean up this part that's like inside these brackets. Well, this is a negative exponent that I would flip down. So this would be like x squared plus 1 times 1 over 2 square roots of x. All over, well, if we have the 1/2 power and we square it, this is a power to a power rule. So wouldn't we multiply the exponents, which would give us really 1/2 times 2, which is just x to the first power? Or this is like the square root of x squared, which just goes to x. Well, that kind of turned out kind of slick, right? So moving up here, my derivative of y with respect to x would equal 2x times the square root of x. Well, if I have one part that's a fraction, it's easiest if both parts are fractions. So this is x squared plus 1 over 1. So we're just multiplying straight across. So minus, and then we would have x squared plus 1 over 2 square roots of x. All of that, it's really easy to lose that denominator, and the denominator squared is simplified to just x. So a lot of people will go, okay, so this is really just one fraction. We're just subtracting all this one fraction, so I don't really need the brackets there. And if I make everything a fraction because it's easier, then this is over 1. And maybe, I don't know, to subtract fractions, we might need LCD. So what in our LCD? Our lowest common denominator would be 2 square roots of x. So this one has that, this one's missing that. So I'm going to multiply by 2 square roots of x to the numerator and denominator to produce my LCD. So that would give me dy over dx equals, so 2 times 2 would give me 4. This x would still be there. Isn't the square root of x times the square root of x just x? Minus, but then we're subtracting all of this, so maybe keeping those brackets there would help. You realize you're subtracting all of that numerator. So if I distribute that negative through, it would be minus x squared minus 1 all over the LCD. I mean, that's the reason we get the LCD, right? So we can string the numerators together all over that lowest common denominator, all over x. So now I'm down to dy over dx. Well, 4x times x would be 4x squared. So if I just like simplify this one little part, this would be 4x squared. Minus this 1x squared. Well, hey, these are like terms. So that would collect to give us what? A 3x squared? 3x squared minus 1. All over our LCD's 2 square roots of x. And you guys, isn't this really one fraction divided by x over 1? Oh, that's another fraction. So don't we want to copy dot flip that bad boy? So there's me copying down the first fraction times flip or reciprocate the second one, 1 over x. So I'm down to dy over dx equals 3x squared minus 1 over 2 times x, maybe pull that in front, times the square root of x. And that would be my derivative of y with respect to x. It's the same thing as thinking about like y prime, or it's the same thing about thinking about the derivative. They all really mean the same thing. So whether you want to think about it as the bottom times the derivative of the top, minus the top times the derivative of the bottom, all over the bottom squared, that's the same thing as low d high, minus high d low, all over the square.
You gotta
below.
sing it.
And you gotta sing it. Mr. Herney wants you to sing it. Okay? So that was a lot of examples of quotient rule. That's probably the harder one and the one that you'll need more often. Sometimes you can avoid product rule, and you just have to realize you just can't take the derivative of the top and divide it by the derivative of the bottom. That is not right. If it's two functions that are multiplied together, you have to use product rule. If it's two functions divided, you have to use quotient rule. Last minute thoughts, Mr. Herney?
Just make sure you sing it.
Okay. Bye.